So generally for constructing a wall, generally like sheet pile or soldier pile, these things can be as a cantilever wall for a depth of 4 to 5 meters. Like other second pile, so second pile contiguous or diaphragm wall can be a depth of 8 meters. Excavation we can go as a cantilever wall. Beyond that, you need a proper arrangement, strut or anchor system for maintaining the deflection, or else the stability of the structure is not maintained. So we need a prop system for maintaining the stability. Generally, when for cantilever system, again you need to go for a deeper depth of embedded portion. So the embedded portion can be a when we are going for deeper depth, still the design becomes uneconomical. So we can have a strut arrangement to reduce the embedded portion and reduce the length of the wall. But you can, because this is a temporary strut arrangement, after the construction you can remove the strut arrangement also. So the propped system is more useful for maintaining the stability of the wall. There are two predominant types like strut, and then we will be using the anchor. Compared to cantilever, as I said, compared to cantilever wall strength stiffness, suppose if you are going for a cantilever wall, you have to go for high stiff wall or like bigger size of the wall. It will be uneconomical. The thickness of the wall will be increasing. So the strut arrangement helps us to reduce the thickness of the wall also. So this is a general strut arrangement. This is just for a type of construction like where only the corner struts are used. For other cases, there are like main struts where it will be used when the length of the excavation is more. Generally, for strut arrangement, there can be pipe sections or UC sections used for the strut arrangement, and moreover these are reusable. So once it is used for one construction, this can be again used for the other constructions also, and this can be used for the available material. For some contractors already place some materials which is available at the site level, so we can use those design. Actually, this has to be designed for the forces. Next is the anchor system. Strut system is more used than anchor system. One limitation for the anchor system is like you need enough space for the anchors, like it cannot infringe into the nearby structures. So anchors, this is also like stage-wise construction. You go for one anchor, then after excavating, you go for the another anchor. So we can see the advantages and limitations of the ground anchors. Like compared to strut system, in strut system, the strut is placed inside the excavation, so it is little difficult for the construction of the main structures. But in anchor system, you have ample space for the construction. But the compared to strut, the anchors takes less compared to strut. The anchors can be pre-stressed to reduce the wall deflection. The ground anchorage pre-stress may reduce the wall deflection and settlement. The ground anchorage often extend outside the site boundary, and the necessary permissions are required. Like suppose when our construction, as I said, when our construction is limited and we don't have ROW, so when we go for deeper excavation, the anchor length will be increasing for the fixed length and free length. So to reach that fixed length, you have to go beyond the excavation area. So we should be able to understand nearby there shouldn't be any pipe foundation or other constructions activities or any other foundation which can affect those constructions also. But for the installation of these ground anchorages also increases the time and compared to strut. And after construction, the ground anchorages should be de-stressed and sometimes it should be removed. So when it comes to ground anchors, there is delay and cost increases compared to the studs. But only benefit for the anchors is you can have a free space for the construction, so it won't affect the construction purpose. But you need there are some other limitations, like in many places you cannot go for the ground anchors. Sometimes the drilling of ground anchors and grouting can also induce some wall movements. So these prop systems are the main for the excavation, and when it comes to deeper excavation, like when it is more than 8 meters, we have to go for the either anchor or strut arrangement for deeper excavation. So next to this, we'll be looking some basic fundamentals. For this construction, we have to, the basic is the earth pressure theories. So basically we know that when a retaining wall is there, there are three states like at rest condition, active state and passive state. At rest condition, when there is no movement in the wall, it is called at rest condition. When active state is the state where the wall is moving away from the soil, and passive state is when the wall moves towards the soil. So generally when there is an wall present, the wall, the soil which is retained is the zone where it is called active zone, and the wall which is embedded and the soil which is present before the wall is the passive zone. These are the basic things, like where active state, passive state condition is defined. Like you can see that when the wall is moving away from the soil, the weight of the soil verticality comes down overall, and then this has to be the forces has to be equilibrium condition has to be retained to find out the stability of the wall. Generally, the wall movement is predicted from these theories. There are more common theories we will be using is Rankine's theories and Coulomb's theories for predicting the earth pressure calculations. Rankine's theory is based on a stress state that can be in equilibrium without exceeding the limit strength of the ground. So the limiting ratio of horizontal to vertical effective stress is constant in this theory. So the vertical stresses increases with the depth. This will be having a limiting horizontal effective stress. Usually calculate the limits calculated using this theory ensure stability, but sometimes it can be correct boundary conditions, and using strength parameters has to be identified for these theories. The second most common we use is Coulomb theory. This comes from this is like when a retaining wall to prevent a wedge of soil from sliding down, an assumed slip surface is determined. This usually assumed to rise from a stress that increases linearly with depth. This limit obtained will prevent sliding, and the slip surface assumed is the calculation. But this for sometimes this can be also an unsafe condition. So the most compared to this, we will be using Cacat-Cursel for theories, which is more commonly used even in many softwares also. There is a comparisons in this, like how these theories are placed. Like initially for Coulomb's theory, we will be using planar failure surface. For Rankine also we are using planar failure surface. But in Cacat-Cursel we will be using curved failure surface. So Padfield and Mayer is the one like some recent theories which is adopted in many softwares also. So they take the adhesion factor of the wall into account. So for like Rankine's theory and Coulomb's theory, they give the result for the smooth backfill wall. Suppose the backfill is inclined in Rankine's theory, cannot be used. So there are some limitations for Rankins theory. So these are just common theories which is used for the calculation of depth pressures. These theories can be used for when the depth of like cantilever walls are like minimum prop system, but when the depth is very high and we are going through some softwares where which will be helpful for us to solve the solution. There are several types of softwares in the markets which is used common. But we'll be discussing few things for when it comes to big projects, softwares are used. So when the first one is a limit equilibrium approach. This you need only a ground strength, and these softwares are simple and straightforward, and it's very simple. So there is no soil structure interaction in this, and also we cannot calculate deformation in these softwares, which is more like a 2D software. So next is like subgrade reaction softwares like VALAP. Those things are works under this subgrade reactions. This like soil is modeled as elastic springs. Interaction between the ground and the structure is taken into account, and wall movements are also calculated. This is also like more like a straightforward software, and 2D. We can use only 2D models in this. But the wall movement is calculated, but the ground movements near the wall is not calculated in these softwares. And then pseudo finite element. This is also like software like Few, VALAP, or works under the principle of pseudo finite element. Interaction between the ground and structure is taken into account. Wall movement is also taken into account. Simple 2D software, more like just an input and you get an output kind of thing. There is an option in VALAP itself, like you can go for subgrade reaction model or pseudo finite model. Next is like finite element and finite difference model. It's more like a soil structure interaction. The picture which you are looking into is from the Plaxis, results from Plaxis for the excavation. So you can model some complex ground models through using these type of softwares. Like you can go for different stage-wise excavations, and also you can see the wall movements and even the nearby ground movements. It can carry out both in 2D and 3D also, but this when it comes to 3D, it is a little bit of time consuming. This quality of the model also depends on the experience of the person who is using the model. So more knowledgeable thing person can have very good results in this software. So you can model all the structures in this softwares. So you will get soil structure interaction in this finite element softwares. So next we will be discussing one case study like for a soldier pile wall system. We have to construct footing at a depth of around some 5 meters below the ground level. And the soil layer present for that area is silty sand. For up to 4.5 meters, it is silty sand. After that, we have a residual soil. Below that 7.5 meters, it is completely weathered rock. So here, for this type of excavation, you selecting a wall is just I'm saying like how we can select a wall. Like this is a temporary excavation, so we have to go either for soldier pile wall or even in sheet pile wall. So soldier pile wall, we cannot go for a diaphragm wall for smaller shoring system. And other like second pile or contiguous pile wall, you have to have a boring rigs and you need equipments to boring for those cases. So it's not a economical thing for going for a second pile or contiguous pile wall or diaphragm wall. So soldier pile wall is chosen. It is economical and there is no water table. So soldier pile is used for that shoring arrangement. Here you can see the excavation for the depth is around 5.1 meter, In between you can see some footing size of 2.2 meter. So the width of the excavation is 8.1 meter. Here you can see some rounds. These are soldier pile wall, and between that lagging is provided. After that mailer beams is provided along the length, and in between to the state one level of strut is provided for the limiting the deflection. Here the arrangement is not box type. Here we have got like both the sides we have slopes so that it can access for the bottom of that excavation. The materials, after design, this design is carried out using some plaxis. So after that, for the forces, we need to design for the soldier pile wall, and required for that required forces, strut and valor is designed. So for these cases, for a depth of 5.1 meter depth, soldier pile of ISMB 200 is used. You can see the embedment depth is 1500 mm, that is 1.5 meters, and the excavation depth is 5.1 meter. One level of strut is used to control the deflection, and it is placed at 1 meter below the excavation level. Here the lagging is used as a wooden lagging. 100 mm thick lagging is used. And the spacing between the soldier pile is 1 meter center to center, and strut of ISMB 600 plates is used, and valor of ISMB 600 is used. So valor is the one which is placed at the strut level. So this is the cross section of that excavation. You can see the soldier pile. Below that the embedded depth is 1.5 meters. So these are the more common embedded retaining walls which are used in the construction sites. It can be a temporary wall or a permanent wall, and the design of these walls is required for the construction of many projects. If you are able to understand the design, like the basic design is earth pressure theory. From that you have to design the design the type of wall. Like initially you should understand the type of the wall, which wall is suitable for which type of construction, and whether it is for the permanent or temporary, and based on that the wall is designed. So where all these walls are used is particularly in metro projects. So when it comes to underground construction, the walls used for construction of underground metros, like diaphragm wall, is used predominantly in many metro projects. Other than that, stick and pile walls are also used in some cases for temporary excavation. Soldier pile and sheet piles is used for like ancillary building constructions, those things. So for in metro projects, there are many metro projects, ongoing metro projects, and then many upcoming metro projects. Each and every city is having a metro, and they are planning for projects like Chennai Metro, Kanpur Metro, Surat Metro. These are some upcoming tender projects where there is a lot of job opportunities. So when someone is able to understand the design of these embedded retaining walls, you have a good scope in working in these metro projects. Next is road projects. For in road projects also, in some cases these retaining walls are used for the construction of like bridge foundations, those things. Next is like ports and harbors. When there is a construction of a coffer dam, other ports constructions, these sheet piles are predominantly used in ports. So there is when this design is understood, you can be able to work in many ports projects. And basement constructions, like when we are like constructing some commercial building, and nowadays there are many buildings which has a basement of -3, -2 below the level. So for these constructions, you have to understand the embedded retaining concept. Embedded retaining wall is predominantly used for the construction of these projects for the underground construction. And then for rail projects, like normal rail projects itself, just deflection when there is a construction nearby railway tracks, those things, the deflection criteria is one of the main criteria. So you have to restrict the wall movement. So for that cases, many embedded retaining wall is constructed, shoring arrangement is placed to reduce the deflections. So when it comes to an underground construction, embedded retaining wall is a more common wall system. So there are several types like sheet pile, contiguous pile, soldier pile wall, and diaphragm wall. So when the designer has to understand which type of wall is to be used for which type of construction and method of construction, and next is the availability of equipments for the construction, and then the necessary materials available for the construction nearby. So some are temporary cases, like suppose if we are going for a sheet pile, if the contractor has some same sections available nearby, can reuse those sections. So there is like temporary and permanent type of walls, and also the method of construction like top down and bottom up. So when a designer understands these aspects, he is able to use the correct embedded retaining wall for the construction, and this can help him save the cost and time for the construction.